Hi folks, in this video I'm going to show you how to answer question 30 from the HSC 2020 paper. A chemist discovered a bottle simply labeled C5H10O2. To confirm the molecular structure of the contents of the bottle, a sample was submitted for analysis by infrared spectroscopy, proton NMR, and carbon-13 NMR spectroscopy. The resulting spectra are shown. In the space provided, draw a structural formula for the unknown compound that is consistent with all of the information provided. Justify your answer with reference to the information provided. The first thing is we have a picture of an IR spectrum. First things first, when you come across an IR, you simply look up the data and then you draw up a table. So then you begin to piece together the type of information that you should be seeing. We're going to really focus around this area first. 3230 over 3535. This signifies OH. So basically we're trying to figure out if there is a COOH. Some of the possibilities you can already have a think. Between 3230 to 3550, there wasn't a peak. In that case, if we don't have an OH, it's unlikely that our functional group is this guy. And it's also unlikely our functional group is this guy because they both share OH. The reason I know that it is not an aldehyde is because, first of all, we can look at the carbon NMR. Is there a possibility that there is a ketone? We just eliminated that, and that, but surely there must be a ketone somewhere. So that's the next thing we need to have a look. And the ketone usually exists between 1680 to 1750. And it should be a strong absorption peak. Contenders are between a carboxylic acid and an ester. But I've already described to you that there were no OH. That's the information we have, and I'm going to leave it there. Now we look at the proton NMR and the carbon NMR. The first thing I actually want to tell you is, unofficially, the way you tell how many carbons there are in a system is to look at how many lines there are. So there's one there, there's one there, and then this part is just a zoom in region of that. So you have 1, 2, 3, 4. 4 carbons. Your molecular formula has 5 carbons. So this is a strong indication that your structure here is a branched version, not a linear version. Before we look at the proton NMR, I'd like to say a few words on how to understand the chemical shift of the proton NMR, because they're all in different positions. So how do you know which one's which? This is, the right hand side is 0, delta is ppm, right being the lowest number, left being the highest number. When you have something called more shielded, then it's going to be to the right hand side. If a proton is deshielded, then it's going to occur on this side. Let's recreate the structure from right to left. Let's go to B. B is around 2.0. It has an integration of 3. C is septet. Sept means 7. The most common example of a septet, carbon CH3 carbon, hydrogen. Okay, and let's put this as R. You have a mirror image. Carbon suggests that the compound, the molecule is branched. The CH3 here and the CH3 are the same thing. The n+1 rule always referring to the neighbor. We got 6 neighbors. This is the structure of the septet. So it's CR, CH3, CH3, and hydrogen. These two are these ones. So okay, the carbon NMR. This one is going to be the CH3s. And we have 2 lots. According to the chemical data sheet, between 5 and 40, we have CH3. 10 to 70, chlorine, bromine. Well, we don't have that. So we can already say what we don't have. We don't have this. We don't have this because that's 170, that's 190, 220, that's too far away. So the possibility is either the OCH3 or the CH3, which is what I've shown here. All right, I'm going to explain this a bit more. There's a strong likelihood that it is an ester and not an ether. Now when you piece together the entire thing, you're going to culminate all that information. The first thing is to start off with the carbon-carbon structure backbone. 1, 2, 3, 4. This is hydrogen. You can also have this version. As you can see on the ChemDraw diagram, I have two structures there, and they're both C5H10O2. The question is, which one is it? This is the singlet. These two are from proton, which is 6 hydrogen integration. And then this guy is a septet and 1 hydrogen. That is, if you think about it, exactly the same as what you see here, here, here. And you also see a singlet. But yet, the structure is a bit different. The oxygen is between the carbon now and the CH3, while in the second structure, the oxygen is between this branched set of carbon chain and is next to the carbonyl. So what this part is this part. The main difference is this one and then this one. This is the proton NMR prediction of structure A. The CH3 signal lies here. This is where CH3, okay? As I highlight the cursor, this thing lights up. So this is around 3.7. Let's look at the other one. The CH3 here is at 2. The CH3 that's next to the oxygen is de-shielding. So it's going to be more to the left of the NMR spectrum. The CH3 that's next to carbonyl is shielding, and so it's going to be more to the right of the proton NMR spectrum. So that's your answer. I hope you enjoyed this demonstration, and I'll see you next time.